Hi everyone, I hope you're doing well. So I've gotten 2 questions recently that we haven't had the time to answer in class or in office hours. The first question was from the ionic bonding asynchronous work you had, specifically from the optional problems, and it was magnesium and oxygen, looking at the bond that would form there. The second question was from your covalent bonding practice, the one about silicon and again oxygen, and so this was from covalent bonding. So I thought I'd send this quick little video to help you out with these 2 different examples. Feel free to watch just one or the other or both. All right, so starting with number 1 here, magnesium and oxygen. I tell you it's from the ionic bonding worksheet. Let's double check that we know why magnesium and oxygen would form an ionic bond. I see magnesium over here at number 12. I look at my color coding. This yellow color is an alkaline earth metal. That's a type of metal. So I have magnesium, which is a metal. And then I also have oxygen. Oxygen is number 8. And this pink color is other nonmetals. So oxygen is a nonmetal. I know when a metal and a nonmetal combine, that forms an ionic bond. And an ionic bond is when one atom donates an electron, the other atom receives the electron, and then I get a positive and a negative ion that results, and those 2 ions are attracted to each other. So if atoms are donating or receiving electrons, they form ions, which means that they have a charge. I get 1 positive ion, 1 negative ion, or potentially 2 positive ions, and 1 negative ion, or 2 negative ions, and 1 positive ion, some positive, some negative, and they're going to be attracted to each other. So let's figure out how many magnesiums we need and how many oxygens we need in order to form this bond. I always start by drawing the Bohr diagram for the neutral atom. So magnesium is atomic number 12, meaning it has 12 protons, meaning if it's neutral, it's going to have 12 electrons as well. So in order to fill my electrons in the first energy level, there only goes 2 electrons. Always, 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 when I'm filling electrons and energy levels, the first energy level has 2 electrons. Second energy level has 8 electrons. Again, I'm trying to get to 12 for magnesium, so I'm up to 10. And then I need a third energy level. Excuse my bad circles here. I need a third energy level, and I'm going to put 2 electrons in that third energy level. That makes sense to me that there should be 2 electrons in the outermost energy level, also called the valence energy level, because you'll see magnesium is in group 2. Every element in group 2 has 2 valence electrons. All right, oxygen, I'm going to do the same thing. So oxygen is number 8. And so I only need to get to 8 electrons total. So 1, 2, 3, 4, 5, 6, and then 7, 8 from the inside. So these would be the Bohr diagrams for the neutral atoms. Now I need to figure out how the atoms are going to donate and receive electrons. Magnesium has 2 valence electrons, so it's going to tend to donate that 2 rather than gain 8 to get to a full valence shell. So it wants to donate that 2. Oxygen has 6 valence electrons, so it's easier for oxygen to receive 2 electrons rather than trying to donate all 6. So oxygen wants to receive 2 electrons. So what's going to happen? Magnesium can actually give both of its electrons to oxygen. Sometimes we only give 1 electron, but in this case, magnesium is going to give both of its electrons to oxygen. When magnesium gives up its 2 electrons here, you'll notice this entire energy level disappears. The new valence energy level is now full. When oxygen receives 2 electrons, oxygen is also now full. Full would be 8 valence electrons. So we knew that magnesium had to give up its 2 valence electrons to oxygen because we're looking for what combination will leave both ions with full valence shells. What combination will leave both ions with full valence shells? In this case, giving up 2 electrons leaves my magnesium with a valence shell and my oxygen with a valence shell. So the molecule that results is magnesium oxide. Magnesium oxide. And so I'm naming that based on needing 1 magnesium and 1 oxide. So I don't need to add any numbers down underneath the magnesium or oxygen because I just needed 1 and 1. All right, I hope that was helpful. In my next video, I'm going to talk about the covalent bond between silicon and oxygen. So if this was helpful, go ahead, keep on watching. I will talk about silicon and oxygen.